In this video, the objective is to simplify variable expressions containing no parentheses. You will learn about commutative property of addition, associative property of addition, like terms, and then how to collect them and how to add them. What is commutative property of addition? If you have two numbers, a plus b equals to b plus a. What do I mean? What is 2 plus 3? 5. What is 3 plus 2? Again, 5. They are equal. This property is called the commutative property of addition. It means that it doesn't matter. Order does not matter in addition as long as everybody is being added to each other. The minute we have one subtraction in the middle, we cannot move things around. What is associative property of addition? It means that if you have 3 numbers, it does not matter which 2 you add first. This bracket shows that we want to add B and C first and then add A to them. And here the bracket shows that we want to add A and B first and then add C to them. So if I have 2 plus 3 plus 10, if I want to put these two in bracket, it means that we need to add 3 and 10 together first. What is 3 plus 10? 13. What is 2 plus 13? 15. On the other hand, if I have 2 plus 3 plus 10, meaning that I first want to add 2 and 3, what's that? 5 plus 10. What's the answer? 15. They are going to be equal. This is called the associative property of addition. Keep these in mind. We will be using them in a minute. I want to talk about like terms. What are terms anyways? Terms of variable expressions are the addends of the expression. It's the little things in an expression. So for example, if I have 3x plus 5 minus 7x, plus 7x minus 2, here we have 4 terms. There are 4 terms in this expression. What are like terms? Like terms are the terms that have the same variable. 3x and 7x are like terms. And plus 5 and minus 2 are our constants. I'll give you another example. If I have 5a plus 2b plus 8a plus 10b minus 3a. How many terms do you see in this expression? 1, 2, 3, 4, and 5. There are 5 terms. They're added or subtracted with each other or to each other. Since 5a and 8a and negative 3a have a common variable, which is the a, we call them the like terms. These are like terms. 5a and 8a and negative 3a are like terms. You can add them or subtract them. And 2b and plus 10b are like terms as well. To be or not to be here, right? I always say that you can look at a variable as something that represents something that you like. For example, in my examples, always A's represent apples and B's represent bananas. This is like my story if I go grocery shopping. I buy 5 apples and I pick 2 bananas. Then I buy 8 apples. And then I buy 10 more bananas and I eat 3 apples. And at the end of the day, after after you collect them, if I ask you, okay, how many apples and how many bananas did I purchase? That is adding and subtracting like terms. We want to do that. One of the good things that you can do is just to organize your algebraic expression. Collect the like terms and put them together. Let's look at the first one. I'm going to write down the 3x. I'm going to bring 7x with its sign, which is plus, and write it right beside 3x. Then I'm going to write down plus 5, and I'm going to bring negative 2 and write it with its sign right after 5. Now I'm going to add them. What is 3x plus 7x? This is 3x, and this is 7x's. What are they? What do we have? 10x, right? 10x, that's it. What is plus 5 minus 2? You gain 5, you lose 2, so the result is plus 3. Let's look at the second expression. Let's collect the like terms, put them together. 5a plus 8a minus 3a. So first I'm going to write down the terms with the variable a all together. This is called collecting the like terms. Then I'll continue, just going to go and write the rest of them down. Plus 2b plus 10b. It's called collecting like terms. Now I start performing the operation of them. How do we add like terms? First of all, I put them in two different categories, groups. The a's together, the b's together. 5a plus 8a minus 3a. You're gonna copy the variable without changing it. You're not gonna make it a2 or a3 or anything else. A is A, apple is an apple. You are going to add the coefficients or subtract the coefficients. So what you literally have to do is just copy the 5 and go 5 plus 8 minus 3 and perform this operation. By the way, this is what we can do, right? We can add letters. These are we can add numbers. So what is 5 plus 8 minus 3? 5 and 8 is 13, minus 3 is a 10. That's why the result of these three variables, alike terms, is 10a. We're going to do the same thing for these two. Plus 2b plus 10b. You have 2b's and 10b's. What do you have? A big hive, right? Not so much a big hive. Anyways, 2b plus 10b is just 12b. Let b be anything that you want. Bees, bananas, binoculars, whatever. What matters is that the next step cannot be done. We cannot add apples and bananas. We cannot add apples or binoculars. We cannot add A's and B's. We just go leave it like this because they are not like terms anymore. Once they're not like terms, you're just going to go and leave them like that. Let me throw in a question that you have not seen. How about this one? 6 z plus 8 minus 5 z. Do you see any like terms? Collect them. So I go 6z minus 5z. And then we're going to write down the 8 at the end, which is, by the way, a constant because there's no variable attached to it. So what I'm going to do right now is going to add these two together, or actually subtract the 5z from 6z. 6z minus 5z. So it's like you have 6 of them. 1, 2, 3, 4, 5, 6. You take away 5. Let's take away 5. 1, 2, 3, 4, and 5. How many remains? 1z, right? We're just going to go ahead and write it down as z or z. Just going to go copy the plus 8. What's the coefficient for z here? It's just a 1, right? we do not write down that coefficient. When you have 1z, you have 1z. You're just going to leave it like that. So the result to this is z plus 8. Or z plus 8. But nothing else. Nothing more than that, eh? Okay.